we shall continue with nuclear and particle physics, and today we are going to discuss about betatron. It's a type of particle accelerator, betatron. We shall give the principle of betatron, the construction and working, and also the derivation, physics behind the apparatus or the accelerator. So the betatron is meant for accelerating electrons and beta particles. Beta particle is nothing but electron. It is coming from within the nucleus. We call it as a beta particle. It is basically an electron with the electron negative charge particle. So betatron, electron both are same. Only the origin is different. Electron can be obtained from atomic shells, whereas beta particle is obtained from within the nucleus, but both are electrons. So this is meant for accelerating electron, so we call it as betatron, electron or beta particle. Cyclotron, already we discussed cyclotron. The cyclotron, there is a relativistic correction needed. That is what happens is when the magnetic field is there, and when the particle goes on with higher speed, there is relativistic correction according to mass, according to Einstein's relativistic equation. When there is velocity of the particle is approaching velocity of light, the mass increases. Therefore, the frequency condition, cyclotron frequency condition will get disturbed. Later we will come to what is called synchrocyclotron to accommodate that. Now in betatron we can go up to 250 MeV. So here we will think about how betatron takes care of this relativistic correction. Betatron can accelerate electrons or beta particles up to 250 million electron volt. So what is the principle behind this? The electromagnetic induction causes acceleration. So we have got electromagnetic induction, we have got electromagnetic induction, that is induction stove also we know. There we get eddy currents formed in the induction stove, but here the electrons are moving around, so they get accelerated faster and faster, they get accelerated. So the electromagnetic induction causes the acceleration of the electrons, and varying magnetic field accelerates electron in a fixed orbit. So if you have a magnetic field and the particle is moving in a perpendicular direction, magnetic field is applied perpendicular, then it will have a circular motion, and as the particle increases with velocity, it will go in a spiral path. That is what we saw in the cyclotron, because the energy will go on increasing and it will take a larger and larger radius. But here in the betatron is a fixed orbit. How you make the orbit fixed? By changing the magnetic field. When you are changing the magnetic field, the orbit is fixed. So we will come to that. So varying magnetic field accelerates electrons in a fixed orbit, unlike in the cyclotron. You have to have a comparative study. Cyclotron was a spiral orbit, here it is fixed orbit. So the construction, it consists of a donut shaped chamber. So here we have got a chamber. This is the chamber consists that is, it is like a, suppose a rubber tube I take a rubber tube, both ends are open, so it is a hollow rubber tube. I just put them together, join them together, that is a donut shape. So it is a pipe which is a spherical, inner space is spherical. So you take a long pipe, flexible pipe which is a rubber tube, and then you put them to the two open end, you put them together, that is donut shape. So that is what we have done here. See here this one. So this is the tube like, and it is connected together. So it is a inner chamber is hollow, inner chamber is hollow, and this is empty space. So this is the tube is here, and the electron is going to orbit inside that donut shaped tube. It is, in other words, it is like a shape of a vadai. So vadai, there will be a hole at the center and we will have the chamber. So that is a donut shape. And some of us would have tasted donut, so you know the shape of that. The chamber is that shape, whereas in cyclotron it was a disc D, we call it as D. Here it is a donut shape. So the magnetic field is perpendicular to the plane of the orbit of electron. So here the electron, inside the electron is going to be injected. We have got the tube, we got the chamber, hollow chamber, and we are at the center, we are just using electron gun. Some few electrons are injected with some energy. Then because of the magnetic field, it will be making circular motion. So what must be the direction of magnetic field? It must be perpendicular to the electron orbit. The electron orbit is in this. If the electron orbit is this way, magnetic field is perpendicular. So it is perpendicular to electron orbit. Magnetic field is perpendicular to the plane of the electron orbit. The chamber is highly evacuated naturally. See this chamber, the chamber, hollow chamber, it should be evacuated. If it is having air or some other gas, this electron will bombard that and it will lose its energy, and or it will cause ionization. Now here if it is vacuum, it will be able to move around without interacting with any other target. Electrons are injected with kinetic energy, some kinetic energy injected into a circular orbit. So here the electrons are injected, that is not shown in figure. The electrons are injected and it will take a circular path inside that hollow chamber. Electromagnet is powered by alternating current. So here it is not a fixed magnetic field. Again you just make a comparative study. In cyclotron it was fixed magnetic field. Here it is not fixed because the cyclotron gave a limitation like a relativistic correction. Here we are not fixing the magnetic field, we are fixing the orbit. Magnetic field is varying. So electromagnet is powered by, because it has to change, it is not a steady magnetic field, it is an alternating magnetic field. So an electromagnet is powered by alternating current. So we get an electromagnet. So we will just go to the theory. Now here the electrons are injected into the chamber down at during first quarter of a cycle when the magnetic field is rising. See, this is the magnetic field, already we said it is from electromagnet. So it will be alternating like this, alternating, and here from 0 it goes up to maximum and then it comes to 0 and then goes in the negative direction. We are interested in accelerating the particle, not in retarding the particle. So the magnetic field should increase. When it increases, the speed will increase, speed of the electron will increase. So where will the magnetic field increase? From here 0 it goes to maximum, maximum is B naught, the magnetic field maximum is B naught, and it will vary only in the 1/4 of the cycle, because this is full cycle, this is full cycle and this is half cycle. Here is 1/4 of the cycle. Only in the first quarter, we call it as 1/4 of the cycle, we call it as first quarter. Only in the first quarter magnetic field increases. So we are interested only in this region. So that's why we have marked here T4 and B0. So the electrons are injected into downward during the first quarter of a cycle when the magnetic field is rising. Now we understand the sentence that I used here. It is rising, it is rising. Here it is falling, here it is rising. We want electrons in a fixed orbit or not. So the electron orbit should be fixed, and so magnetic field should vary. See, one of the two. In the cyclotron, the magnetic field is fixed, therefore the radius goes on increasing. It will take a spiral path. Here we want same radius, the electron to be the same orbit, because the downward shaped tube, so it should go only inside the tube. So for that magnetic field should vary. Now we will go to the theory. How are you going to change the magnetic field? Fixing or not, keeping or not constant. So we want the electrons in a fixed field or not, and so magnetic field should vary. Now we will go to basic Lorentz force. We got the Lorentz force BeV. Already electricity we have studied. The Lorentz force is nothing but is a force due to magnetic field. So if a particle of charge, some charge is moving with some velocity in this direction and the magnetic field is applied in this direction, it will take a circular path. That is it. Now see here the electrons are injected, it will move in a horizontal direction, but because of the magnetic it will take a circular path. So that is what the first equation gives. Lorentz force equal to BeV. Now this is also equal to the centripetal force. So we get mv squared by r naught, because r naught is the radius of the orbit, mv squared because the centrifugal or centripetal force is mv squared by r naught. Now these two must be equal, only that it will be in one orbit. See, the centripetal and centrifugal should be equal, then it will be in stable orbit. So we are just equating the two. mv squared by r naught equal to BeV. And we are just cancelling this one V. So, we are getting mv equal to Be r naught. Okay. Now, this mv is nothing but m into v is momentum p. So, we are just writing momentum p equal to B r naught. So, we have come up to this. Now, what is the force acting on the electron? Force is nothing but rate of change of momentum. So, already P expression we had. So, force is nothing but dP by dt. So, I can write as E r naught into dB by dt, because from the earlier expression P is nothing but Be r naught, Be r naught, P is Be r naught. Now, here E is a constant, r naught we want to r naught to be constant, same orbit. So, the variable is only B. So, we are just under differentiation we have got only B. These two constants are taken outside. So, we can also say the force is equal to E into E. See, what is the electric field? Electric field is force experienced by unit charge. Now, here the charge of the electron is E. So, the force is E. This is also force, equation 1 is also force, equation 2 is also force, 1 equal to 2. So, I can write this equal to this, r naught dB by dt equal to E. We are just equating the two. Now, we have found out some expression for electric field and magnetic field, rate of change of magnetic field. So, what is the induced voltage? Induced voltage, because the electric field is E into dl, E into dl, because what is electric field? The electric field is force experienced by unit charge, and force into distance will be energy, and here the particle is moving along a circular path, and what is the distance moved? When it moves in one circular path, the distance moved will be 2 pi r naught, that is the circumference. So, here E is there, integral dl, closed integral dl will be 2 pi r naught. Already in the previous expression we had, see, we get E equal to dB by E equal to r naught dB by dt. So, we are just using it there. So, we are getting 2 pi r naught squared into E0. From Faraday's law, induced voltage equal to d phi by dt. That is Faraday's law, d phi by dt, change in flux. This is flux, rate of change of flux. Now, I can equate these two. So, I will be getting, keep in mind this expression, next expression we will be writing. So, 2 pi r naught E equal to d phi by dt, this part 2 pi r naught E into d phi by dt, this one, this E into integral dl is nothing but 2 pi r naught. So, this 2 pi r naught into E is equal to d phi by dt, that is what we get here, 2 pi r naught into E equal to d phi by dt, and this E I can rewrite, we get this equation 6. So, this is the expression for electric field E. Using this in 3, already in 3, see what is this, this expression, this is E, we have to use this in 3, this one, in the place of E we are just using. Now, we will go back to this. So, we get 2 pi r naught E equal to d phi by dt, or E equal to this part, then using in 3, d phi by dt equal to 2 pi r naught squared dB by dt. So, this is the rate of change of flux, and this is the magnetic flux density. Now, integrating, I can take this, what I will be getting is, if you integrate, we get this d phi, as far as d phi is concerned, here we get dt and dt will get cancelled, we get d phi and here dB. The d phi will change from 0 to phi, because in the first quarter it will change from 0 to phi. So, that is 0 to phi 0. Therefore, we write as phi 0, the upper limit. And in here 2 pi r naught squared, does a dB changes from 0 to B0. Now, here this equation gives the relation between the flux and the flux density that I have to apply. The kinetic energy, we are interested in knowing the energy gained by the particle. the kinetic energy is equal to EE, because E into V, because V is nothing but energy gained per potential energy or work done in carrying unit charge. The work done in carrying charge E is the energy. So, E equal to E into V, and already we have got expression for V. Therefore, this E we write, V is nothing but d phi by dt according to Faraday's law, d phi by dt. So, we are just substituting there, and this d phi, this is change in flux 0 to phi 0. In first quarter it changes from 0 to phi 0. Therefore, we write as E into phi 0. And in the first quarter, what is the change in time? Change in time is 0 to t by 4. So, we are writing this dt as t by 4, this part. And then we, by rewriting, we get this one, E phi 0 into 4 by t. So, this part, this d phi by dt, this is from Faraday's law, and this d phi, you understand why we write as phi 0, because in the first quarter the flux changes from 0 to phi 0, first quarter, that is the change in flux. In the first quarter, what is the change in time? 0 to t by 4. Therefore, we write in the place of d phi we write this, and in the place of dt we write this. So, we get this expression. Now, E equal to E phi 0, and this t we are writing like omega by 2 pi, because omega is equal to 2 pi by t. Omega is angular frequency, which is 2 pi by t, where t is the period of oscillation and omega is the angular velocity of oscillation. So, this is a well known relation. So, therefore, we write this expression we write, equation 8 we get for energy gained. You remember, E into phi 0 omega. So, it is a function of omega and phi 0. E equal to, already we have got expression for this one, phi 0 4 into omega. Now, here we write this part, because that phi 0, you just remember, see here we get phi 0, and already written an expression relating phi 0 and b 0. So, we are just substituting that here. We get E into 2 pi r naught squared 4 omega b 0. So, phi 0 is written in terms of b 0. So, we get this expression, and simplifying this we get this. So, the relation between phi 0 and b 0 already we are given in 7. So, we will just recall that, this part. See here, this, for this reason only we have derived this expression, relation between flux and flux density, relation between flux and flux density. So, we get this last expression for energy. So, this is the equation 9, gives the energy gain in kinetic energy of orbiting electron. So, in that one quarter it is getting accelerated, then next quarter similarly the first quarter it will get accelerated, which means this is the energy of the kinetic energy during the first quarter, the kinetic energy of the orbiting electron. And what is the total distance travelled in this t by 4 second, 1 quarter of the time period, it is getting accelerated. Already we have discussed that. So, we get this curve only in the first quarter. So, only in t by 4 it gets accelerated, after that no acceleration, because only when the magnetic field is increasing it will get accelerated. What is the distance travelled in that t by 4 second? So, the total distance equal to velocity of the particle into the time, velocity into time. So, the velocity is v and time is t by 4. T by 4 we can write as 2 pi by 4 omega, because omega is equal to 2 pi by t. So, we are writing t in terms of omega. So, we get this, that 4 is there, t is written as 2 pi by omega. So, we get this. So, this is the distance travelled. Now, we will just go further to find out the energy. So, total distance travelled is this one, the same one, we are just cancelling out, see, because we get 2 here, 4 here. So, we get 2 and 1 2 will get cancelled, therefore, we get this expression 10, v into pi by 2 omega, that is equation 10. Now, what is the total distance travelled in one orbit? In one orbit, what is the distance travelled with the electron? In one orbit, it is 2 pi r naught, because it is making a circle the circumference is 2 pi r naught. So, in one orbit it will take 2 pi r naught is the distance. Therefore, total number of orbits will be total distance travelled by this one. The number of orbits will be this by this by this. Total distance by distance travelled in one orbit will give you number of orbits. So, we are just simplifying that. See, this pi will get cancelled. So, we get n equal to v by 4 omega r naught. This is the expression for number of orbits. See, in that quarter, in the quarter cycle, when it will go from 0 to t by 4, in that duration, how many times the electron will orbit. So, this is it. This equation 11 gives the number of times the electron will orbit, keeping the radius constant. So, the total energy, what is the total energy gained by this electron? Because it is basically, betatron is a particle accelerator. So, we want to know what is the total energy gained. So, the total energy gained will be energy in one orbit into number of orbits. That is a simple arithmetic. Number of energy in one orbit into number of orbits. So, the 9 gives energy per orbit, 11 gives the number of orbits. So, this into this, we are writing this into this, 9 into 11. So, we will just go back and see this one, this is 9, energy of the energy gained in one orbit. Then we will go to 11, see this is number of orbits. So, that into this, that is what we do, and we get 9 and 11, we get this into this part. So, we will get all that omega, all that will get cancelled, and finally, we get E r naught b 0 v, that is equation 12. So, this equation 12 gives the total energy gained by the particle. Based on this, we will just you can try a numerical problem. That is, this is the energy is this part we are writing. This is energy gained in one orbit. Into number of orbits, if you multiply, I will be getting the total energy. So, the energy gained in one orbit, this was equation 9, I think it is 9, we will just go back and see. See this one, equation 9, 4e omega r naught squared b 0, that is it, that is equation 9, gives the energy of one orbit. This one, we are writing this expression. In one orbit, we want to calculate what is the energy, and this is betatron, it is meant for the electron, it is for electron or beta particle. So, the charge is 1.6 into 10 power minus 19 coulomb. So, that is a standard value that you can use, and omega, it will depend on the betatron, what is the frequency we are using. So, we have to know what is the frequency at which the betatron is functioning, and r naught is this, depends on the size of the betatron. We have got 1 meter or 1.5 meter. So, the size of the betatron will decide the radius of the orbit, electron orbit, and it will also depend on the magnetic field. So, the energy will depend on, you have to increase the frequency, increase the radius, and magnetic field should be large. Then we get a good energy in one orbit. So, now we have just a numerical problem. A betatron is powered by an electromagnet of frequency 60 hertz. 60 hertz, because this is very slow, 60 hertz is very slow, because in that one quarter it has to make large number of revolutions, and then in that one quarter it will get energized. So, you have to see how many times it will rotate. This is for energy of one orbit into number of orbits you have to see. Number of orbits, already it is only basic arithmetic, energy gained in one orbit into number of orbits. Number of orbits will be that distance travel, velocity, we know what is the circumference, 2 pi r naught, from that you can calculate. 60 hertz, which produces a magnetic field of 1 Tesla. If the radius of the electron is 0.5 meter, calculate the energy gain. So, we got all the data here, 4 into 1.6 into 10 power minus 19 joule, omega is equal to 2 pi f. This f is 60 hertz. So, 2 pi f we can use, r naught is 0.5 meter, b 0 is 1 Tesla. All this if we calculate, you will be, because we are using MKS, all that if you calculate, you will be getting in MKS, which will be in joules, energy in joules. And we want to convert in nuclear physics and also particle physics, we are using only EV, MEV, KEV, all that. Therefore, we wanted EV. Also, just to recall, already you would have studied, 1 EV equal to 1.6 into 10 power minus 19 joule. So, what you are getting will be in joule, you have to convert it to EV. Okay, so based on that relation, you can calculate, you can just check up whether you are getting 377 EV. We have discussed the principle and working of Betatron with the necessary theory. So, here when you study, you think about cyclotron and also Betatron. Cyclotron had its own limitation because of the relativistic correction. In a cyclotron, magnetic field is kept constant. Therefore, the electron will go in a spiral path. Finally, at the peripheral it will come out. Whereas in a Betatron, it will have same orbit. Therefore, the orbit is same, magnetic field is changing. And we have found out what will be the energy. The energy will depend on the radius, size of the Betatron, and it won't be very big, like maybe 1 meter, 1.5 meter. Unlike a linear accelerator, which will occupy so much space because it has to travel in a straight line. But whereas in a Betatron or cyclotron, it is traveling in a circular path. Therefore, it will not occupy much of the lab space. It is able to give higher energy output. So, here we will just pose some questions. Derive an expression for kinetic energy gained by electron in one orbit. So, we are just specifying one orbit. Now, we have to just after that we can calculate what will be the number of orbits it can make. And we have just given a numerical example. Again, this is not worked out. So, you can work out and see, calculate the energy gained per orbit if the applied electromagnetic frequency is 30 hertz, and the applied magnetic field is 2 Tesla, radius is 0.5 meter. So, I will just go back to this one. See, just remember, this is 30 hertz, this is 2 Tesla, and the problem that we had, this one, 60 hertz and 1 Tesla. So, here this frequency in our convert out problem, this has become off, we have made it off. Okay. So, the energy will be off. So, we have made it off, and here it is 1 Tesla, but here we have made it 2 Tesla, double. So, here it is made off, omega is 2 pi f. So, when a frequency is made off, omega will also be off. Made it off, here we have made it double. Therefore, the new problem that you are given, that will also give 377 EV. That is what. That is why we have not given the answer there, because it will be same answer, 377 EV. Here we have doubled, and here we have made it off, here we have made it double. And here think about the radius. Suppose the Betatron slightly increases. So, suppose the Betatron from 1 meter, we are making a cyclotron of 2 meter, then the energy will be increasing 4 times, because it is square. Instead of 1 squared, it has become 2 squared. 1 meter, it has become 2 meter. So, from 1 squared, it will become 2 squared. So, 4. So, the energy output energy will be 4 times larger. So, as the size increases, it becomes 4 times larger, unlike linear accelerator, which occupies a large space. In the next class, we will be discussing about synchrotron, and then finally about the accelerators. We will talk about the latest CERN, that is in European country. We have got the experiment which came out with God's particle, Higgs boson, all that, for which the 2013 Nobel Prize was provided for, given for Higgs. So, we will just complete our accelerated discussion with that one. Thank you.